When we say that a graph has a horizontal asymptote, we're actually making a limit statement. We're saying that either the limit as x goes to infinity or the limit as x goes to minus infinity equals a constant. These three graphs all have at least one horizontal asymptote. The inverse tangent or arctangent of x has two horizontal asymptotes. When you take the limit as x goes to infinity, you get pi over 2. So there's a horizontal asymptote y equals pi over 2. And when you take the limit as x goes to minus infinity, you get negative pi over 2. So y equals negative pi over 2 is another horizontal asymptote. Y equals e to the x has only one horizontal asymptote. When x goes to infinity, the limit is not a finite number. When you get infinity, minus infinity, or a limit that does not exist, it doesn't give you a horizontal asymptote. Whereas when we take the limit x goes to minus infinity, we get the horizontal asymptote y equals 0. So you could have one horizontal asymptote because one of the limits at plus or minus infinity gives you a number, and the other one doesn't, gives you infinity, minus infinity, or does not exist. But you can also have a single horizontal asymptote because the limits as x goes to infinity and as x goes to minus infinity give you the same finite number, as is the case for y equals e to the 1 over x. Every function has 0, 1, or 2 horizontal asymptotes. But you can't have more than 2 because each one has to come from one of these two limits. Consider again the function y equals sine x divided by x. We showed in the last video that the limit as x goes to infinity is 0, and it's not hard to see that the limit as x goes to minus infinity is also 0. So by definition, y equals 0 is a horizontal asymptote. It doesn't matter that the graph crosses this line over and over again. Even if a function is identically equal to a constant, like say this piecewise function, which equals 2 after a point, and equals 5 before some point, we still have that the limit of this function as x goes to infinity is 2, so y equals 2 is a horizontal asymptote, and the limit as x goes to minus infinity is 5, so y equals 5 is a horizontal asymptote. You should be able to identify asymptotes of a function by looking at its graph. What are the asymptotes of gx, and, given those asymptotes, what can you conclude about the limits as x goes to infinity and minus infinity? This graph has a vertical asymptote at x equals 3, and 2 horizontal asymptotes. We can see that when we move to the right in the graph, we're really letting x go to infinity, and g of x is approaching negative 3, so that's where we get the horizontal asymptote y equals negative 3. On the other hand, when we move to the left and x approaches minus infinity, g of x is going to 2, so we get the horizontal asymptote y equals 2. This is a common type of question, which you could even see on the first midterm. You're given a function f and asked to find its horizontal asymptotes. This always means that you should compute both the limit as x goes to infinity and the limit as x goes to minus infinity. Let's consider this function f. Pause the video and try to answer the question. We start with computing the limit as x goes to infinity. Clearly, the fastest growing term in the denominator is x squared, so we divide top and bottom by x squared. When this moves inside the square root, we're really dividing by x to the 4th, and here x squared is positive, so there's no trouble with signs. Once we've done this, we can compute the limit by substitution, and we just get that it equals 2/3. What about the limit as x goes to minus infinity? We still want to divide top and bottom by x squared, but how is the sign in front of that square root affected? Well, when we had a problem like this before, we noticed that when you take the square root of something, it's always positive. So here, the square root of x to the 4th is the absolute value of x squared. But unlike x squared is always positive. So we still get plus the square root of 1 plus x to the minus 4th. It's actually the same as when we took the limit as x goes to infinity, and we still get 2/3. Then we conclude that f has one horizontal asymptote, y equals 2/3. Even though the first limit gave us the one and only horizontal asymptote, computing the second limit is still part of the answer, because we're showing that there's no other horizontal asymptote. So regardless of how many asymptotes you think the function has, you still need to write out what the limit as x goes to infinity equals, and what the limit as x goes to minus infinity equals. Then you need a concluding sentence, which actually lists the equations y equals something for each one of the horizontal asymptotes. In section 4.6, we'll learn how to graph functions in detail by using derivatives. Part of that is going to be identifying horizontal asymptotes, and then drawing a graph that has those horizontal asymptotes you calculated, as well as many other features.